Hey guys, it's your soft-spoken scientist. This is the General Chemistry Lab 3 on stoichiometry and limiting reactants. I'm going to read out each question, show all the work, and explain where each number comes from. Alright, so in this problem, calculate the molar mass of water. What do we need to know about water first? If you guys pull up a periodic table, you'll know that H is 1.01 grams per mole. It's molecular mass. Oxygen's molecular mass is 16.00 grams per mole. So water is H2O. So it's 2 hydrogens and 1 oxygen. That's H2O, which is water, right? So what we need to do is add 1.01 plus another 1.01 plus 16. Or another way you could say it is 2 times 1.01 for the 2 hydrogens, plus the 1 oxygen's molecular mass, right? And by doing that, you'll get 2.02 plus 16, which equals 18.02 grams per mole. So, molar mass tells us how many grams are in 1 mole of a substance. We need this for every gram to mole conversion in stoichiometry. Let's look at practice problem 2, which is a little bit harder, and it'll get harder as we go on. So, how many moles of H2O are in 18.0 grams of H2O? So we're going to use the molar mass from question 1, which we calculated to be 18, right? 18.02 specifically. All right. So what we're going to do is start with the ones that they gave us. So we're going to say 18.0 grams of H2O. We're trying to get to moles of H2O. So in order to do that, I need to get rid of grams of H2O. Cancels out. You must cancel out your units. So we know that we have 18.02 grams of H2O. The reason I know that is because of the molar mass from question 1. And for 18.02 grams of H2O, it's 1 mole of H2O, right? So those cancel out. You basically have, so you have 18 divided by 18.02, which is almost 1, but it's 0.999 moles of water, okay? And I know the mole concept can be a little bit hard for you guys, right? So if I said I had 30, so we know each oxygen molecular mass is 16, right? So O2 would be 16 plus 16, right? Which is 32 grams. So if I had, I don't know, 32 grams of O2, 1 mole of O2. You see what I'm saying? 1 mole of O2 is just saying how many grams, and then you put it in the denominator. All right, so look at this. Grams got canceled. We are left with moles. This is dimensional analysis, so y'all did that right. Let's go to question 3. We have, for the reaction, 2H2 plus O2, and then forming, as a product, 2H2O. And you're given 6 grams of H2, 16 grams of O2. Which reactant is limiting? Well, let's take a good look at this, right? On the left side, which is the reactant side, this is your reactant side, this is your product side, okay? I have 4 hydrogens. I got 2 hydrogens times 2, which is 4. And I have 2 oxygens. Here, I have 4 hydrogens. This is going to be multiplied to the oxygens. I have 2 oxygens. There's a plus sign, so this 2 does not get multiplied to that oxygen. So guess what? I got 2 oxygens, I got 2 oxygens. 4 hydrogens, we're balanced. So they're asking me which reactant is limiting. So let's try to figure that out. First, we're going to need the molar mass of H2, which is 2 times 1.01, which is 2.02 grams per mole. All right. So they told me, hey, you start with what they give you, because the facts are that 2.02 grams of grams per mole, that's something from the periodic table, and that's the way we're able to get into moles, by using the periodic table's molecular masses. So always start with what you're given. Because then guess what? You'll also cancel out the units you don't even need. So you got 6 grams of H2, right? And you got 2.02 grams of H2 for every 1 mole of H2. So let's do the math. Bye-bye grams of H2. And I'm only left with moles of H2, which is what I want. So it would be 6 divided by 2.02, which is 2.97 moles of H2. Let's do it for oxygen now. We got, we got 2. We see that from there. So 2 times 16.00, and you're going to get 32 grams per mole, right? All right, so we're going to start with 16. We always start with our givens. 16 grams of O2 times 32.0, oh gosh, 0.0 grams of O2, right? And what that essentially does is it lets me cancel out grams of O2. So then I'm left with 1 mole of O2. And 16 over 32 is basically, they're both divisible by 16, so I don't even need a calculator for this. I know it's just 1 divided by 2, which is 0.500 moles of O2. So check this out. We got 0.500 moles of O2, 2.97 moles of H2. Step 2 is calculate the product from each reactant. So we have 2 moles of H2O divided by 2 moles of H2, right? That's what we're trying to do. So we're going to take 2.97. We're going to start with H2. You're going to take 2.97 moles of H2. And you're going to divide by 2 moles of H2. And you may be saying, what the heck are you doing? Well, if we look at our balanced equation with this purple star on it, I'm already in moles of H2. I want to go to my product to know which one's limiting. That's the key to knowing which reactant is limiting. Go to the product. Convert everything to the product. So I have 2 moles of H2, and I'm going to head to 2 moles of H2O. So moles of H2 cancels out, and I got 2.97 times 2 divided by 2, which gave me 2.97 moles of H2. You could use a calculator, or you could just say 2 divided by 2 is 1, 2.97 times 1 is itself, right? So you got 2.97 moles of H2. Let's do the same thing for moles of O2. We got 0.500 moles of O2 times, let me use pink to make this really clear. For every 1 mole of O2, remember there's an invisible 1 right here. For every 1 mole of O2, there is 2 moles of H2O, right? So guess what? Bye-bye moles of O2. And I got 0.500 times 2, which is just 1. If you have 50 cents and you double it, you got $1. So I got 1 mole of H2O. So I know 1 is less than 2.97. So I know that O2, which is what I used, is the limiting reactant. The limiting reactant is the one that produces less product. Oxygen can only make 1.00 moles of water, so the reaction stops when O2 is gone. Let's try practice problem 4. Using question 3, calculate the theoretical yield of water in grams. So use your product from the limiting reactant. We have 1 mole of water. And we want to convert moles to grams. Well, because we're trying to get the theoretical yield of water in grams. So I know I had to get to grams. So I have 1 mole of H2O from the last problem because that was the limiting. For every 1 mole of H2O, I got 16 plus 1.01 plus 1.01. So I'm going to get 18.02 grams of H2O. Moles of H2O will cancel out. And I'm left with what I wanted, which is grams of H2O. So 18.02 grams of H2O. All right. Theoretical yield is always based on the limiting reactant. So I'm gonna make a big note when you're doing your labs. Theoretical yield, always use limiting reactant. That's the best way to solve them, or the only way to solve them. All right, let's try problem 5. How many grams of H2 remain unreacted? So we're gonna use the moles of H2 used. So we had 0.500 moles of O2. And if I look back at the problem, I had 1 mole of O2. Now I'll scroll up for you guys. If you check out, you had 1 mole, I'll use blue, you had 1 mole of O2 for every 2 waters and 2 H2s, right? So 1 mole of O2 and 2 moles of H2. That would form 1 mole of H2. The initial H2 is 2.97 moles. So if I do 2.97 minus 1, I get 1.97 moles of H2. So I'm going to take 1.97 moles of H2, and I want to get it into grams. So for every 1 mole of H2, you get 2.02 grams of H2, which would be 3.98 grams of H2, right? So moles of H2 will cancel out. So you got 3.98 grams of H2. Hydrogen was in excess, so some remains after the reaction stops. So if the actual yield of water collected was 14.5 grams, calculate the percent yield. The formula, as we know, for percent yield is actual divided by theoretical times 100. So the actual was 14.5. The theoretical is 18.0, which is what we calculated earlier. Times 100, you're going to get 80.6%. Percent yield compares what you got to what you should have gotten. If you can follow every step here and explain why it works, you really understand Lab 3. Like, subscribe, and remember, STEM is for everybody, especially you.